Welcome back, young math Padawans. It's Mrs. Angel with your lesson for today on solving equations with multiplication and division properties of equality. Just as a reminder, the multiplication property of equality, or MPOE, means that if you're going to multiply one side of the equation, or all terms on that side, you also have to multiply the other side by the same value for that equation to remain true. The division property of equality, or DPOE, states the same thing, except for that we are dividing both sides, all terms on both sides, by the same value for that equation to be true. So let's get into today's equations. Just a quick reminder, when we're talking about solving an equation, we're looking at using these properties of equality to isolate the variable and determine its solution. And the solution is the value of the variable that makes the equation true. So we conduct a check to make sure that that is the actual solution. So as you stated in the intro, we're looking at solving using multiplication property of equality, MPOE, or division property of equality, DPOE. So we're solving these equations using either multiplication or division. Let's look at equation number 1. As always, I like to start by putting a line down the middle of my equal sign to keep the left side separate from the right. Let's start with multiplication. So multiplication property of equality means I have to multiply both sides of the equation by the same value to remain true. So looking at this, I notice that x is being multiplied by 3. So I would think, okay, what if I try multiplying both sides of this equation by 3? Does that isolate x or get x by itself? Well, there's only one way to find out. We would have to simplify. 3 times 3x, well, 3 times 3 is 9, so that would be 9x, okay? And then 3 times 21, well, 3 times 20 is 60, and 3 times 1 is 3, so that would be 63. Now, have we solved this equation? No. What we have done is called creating an equivalent equation, meaning whatever x equals in the original equation equals the same thing in this new one, but x is not by itself, meaning we haven't actually solved anything. So MPOE was not the correct property of equality to use for this specific equation. That leaves us to try DPOE, dividing. Now, again, I notice that x is being multiplied by 3. So I would think, okay, let's go in and try dividing by 3 and just see what happens. Okay, 3 divided by 3. Wait a minute, 3 divided by 3, that's just 1, isn't it? Yeah, 3 divided by 3 is 1. So now this is 1x equals, and 21 divided by 3 is 7. But is x isolated? Well, yeah, because 1 times x is just x. 1 times anything is itself, so we're left with x equals 7. And this is called a solved equation because x is now completely by itself on that side. So as we remember, our reasons are just what did we do. So first, we applied our division property of equality and divided both sides of this equation by 3. Then we went in and just did the math, which is called simplifying. Now, to be sure that this is actually the correct solution to this equation, we need to go in and conduct what's called a check. So starting with my original equation, 3x equals 21, which remember, this means 3 times x equals 21. I'm going to substitute in 7 and see if this equation is true. Does 3 times 7 equal 21? Guess what? 3 times 7 does equal 21. So what I like to tell my students is that it has deserved the solution box, and DPOE was the correct property of equality to solve this equation. Let's take a look at equation 2. Negative 3x equals 21. Again, I start by putting the line down the middle of my equals sign. All right, let's see if MPOE is going to solve this equation, multiplying. Now, one thing I noticed is that this is a -3. So normally what we think is to go in there and add. As soon as you see minus, you think add. But here's the problem. If I try to add a -3x plus a 3, these are not like terms, meaning I cannot combine them. And what I really just end up with is -3x plus 3 on that side. So just because you see a negative sign does not mean that we're going to add. So let's see if multiplication helps us here. What if I were to go in and multiply both sides of this equation by -3? Let's see what we'd end up with. -3 times -3 is 9x, so -3 times -3x, 9x. And -3 times 21 would be -63. Is this equation solved? No, this is again what we call an equivalent equation, because whatever x equals in this equation, x equals the same in the equation we just created, but the equation is not solved. So MPOE is not the property of equality to solve this equation. So that leaves us to try division again, division property of equality. So let's see. If I go in, I'm going to put my fraction bars in, which stand for division. What am I dividing by? Well, what if I divided by 3? Let's see what happens there. -3 divided by 3 is -1. So I have -1x equals 21 divided by 3 is 7. What is -1 times x? That would be -x. And is that solved? No, that's not solved because x is not isolated if it has that negative sign in front of it. So we have not solved this equation. We've just created another equivalent one. So then how can we solve it? It's pretty simple. Divide both sides by -3. Here's why. -3 divided by -3 is +1. So now we have +1x equals, and 21 divided by -3 is -7. What is 1 times x? Just x. And now we have a solved equation. All right, so let's go in and fill in what we did. The first thing that we did is we applied our division property of equality by dividing both sides by -3, and then we did the math, which is called simplifying. But of course, to make sure that we did our math correctly, we're going to go ahead and plug -7 into the original equation. -7. Okay, does -3 times -7 equal 21? Yes, it does. And this equation has now been solved, meaning -7 is the solution to this equation. So both of these equations happen to be solved using division property of equality. And you might notice that both of the equations have multiplication. So division, it appears, solves an equation with multiplication. So now let's look at what happens when we have equations that have division. Do we use division to solve division or something else? I don't know. Looking at equation number 3, though, x divided by 3 equals 9. I'm going to go ahead and put my line down the middle of my equal sign here. And again, we're looking to see whether or not we're going to apply our multiplication property of equality or our division property of equality. Let's see. All right, let's start with multiplication. Now, here's the tricky part. This is a fraction. Notice that this has a fraction bar. So because it is a fraction, we have to remember that fractions stand for division. So by multiplying here, I need to make sure that whatever I multiply, I'm also multiplying it by a fraction. So let's say, for example, I was going to multiply this by 3. That means I'm multiplying by 3 over 1, not 1 over 3. That would be multiplying by 1/3. So in the numerator, you have your multiplication. In the denominator, you have your division. Now again, on the other side, I'm multiplying by 3 over 1. Let's just see what happens when we apply this multiplication. Okay, So as we recall, the rules for multiplying fractions is just to multiply straight across. So that would mean 3x in the numerator, and 1 times 3 is 3 in the denominator. And then on the other side, 9 times 3 is 27 over 1. Now this might look a little messy, but bear with me here. What is 3 divided by 3? That is just 1. So now we have 1x equals, and what's 27 divided by 1? That's just 27. And then finally, what is 1 times x? That's just x. So right now we're left with x equals 27. So is this equation solved? Yeah, because x is by itself. Okay, so let's go in and write in what we did. We applied our multiplication property of equality, and then we just went in and we did the math. That's called simplifying. So it appears that multiplication was the way to go, but the only way to be sure is to check our solution. So taking our original equation, we're substituting in 27 in the numerator of this quotient. Let's see. Does 27 divided by 3 equal 9? Yes, it does. 27 divided by 3 does equal 9, which means 27 is the solution to this equation, and we used MPOE to solve. All right, let's take a look at equation 4. X divided by negative 3 equals 9. I'm going to start by putting the line down the middle of my equation, and let's just see if MPOE applies here. Again, remember this is a quotient, so if we're going to multiply, we have to multiply by another fraction. So here we go. What happens if I multiply by 3 over 1? Again, let's go ahead and just multiply both sides by 3 over 1 and see what happens. Well, that would be 3 times x is just 3x, and 1 times negative 3 is negative 3, and 9 times 3 is 27 over 1. But here's the problem. 3 divided by negative 3 is negative 1, and negative 1x is negative x. And this is not a solved equation because this is a negative x, not x by itself. So how can we change this? Let's go in and multiply both sides by negative 3 and see what happens. Negative 3 times x is negative 3x, and negative 3 times 1 is negative 3. On the other side, we have 9 times negative 3, which is negative 27 over 1. Okay, what is negative 3 divided by negative 3? That's just 1. So now we have 1x equals negative 27 divided by 1 is negative 27, and 1 times x is just x. So now we have x equals negative 27, and multiplication proved to solve this equation. So we used MPOE here, followed by doing the math, which is called simplifying. That's just what we did. But again, to be sure, we want to check our solution to see that we did all of our math correctly, because there's always a chance that we made a mistake. So let's go ahead and substitute in negative 27. And does negative 27 divided by negative 3 equal 9? Yes, it does. 9 equals 9. So that means that this equation is solved correctly, and negative 27 is the solution. So it appears that when your equation has division, we use multiplication to solve it. That's it for today's lesson on solving equations with multiplication and division. I will see you next time.